Hello students, welcome to this lecture 1 quadratic equations. So in this lecture we will continue exercise 4.2. So in our previous lecture we have started exercise 4.2 and there we have solved question number 1 and question number 2. So in this lecture we will start from question number 3. So in question number 3 it said to us find two numbers whose sum is 27 and product is 182. Okay, so here we have to find two numbers whose sum is 27 and product is 182. So let us solve. So here we let the first number be x and the second number is 27 minus x, since the sum of these two numbers is basically 27. Okay, and here we let the first number be x, then will second number is 27 is equal to 27 minus x. Okay, so now their product is equal to x times 27 minus x, and it is given that the product of these numbers is 182. Okay, so therefore we get this equation x times 27 minus x, this is equal to 182. And now if we simplify it, then it implies x squared minus 27x plus 182, this is equal to 0. Okay, so here we get this quadratic equation. Now our task, solve this quadratic equation by using factorization method. Okay, so here we will solve this quadratic equation by splitting the middle terms of this quadratic equation. Okay, so here it implies x square minus 13x minus 14x plus 182, this is equal to 0. Okay, so basically here the middle term splitted as minus 13x minus 14x, so that minus 13x times minus 14x, this is equal to 182x square. Okay, so now if we take out x from first two terms, then we'll get x times x minus 13. Okay, and now from second and fourth term, third and fourth term, if we common out 14, then we'll get minus 14 times x minus 13, this is equal to 0. Okay, so and it implies x minus 13 times x minus 14, this is equal to 0. Either x minus 13 this is equal to 0 or x minus 14 this is equal to 0. Okay, so that is x is equal to 13 or x is equal to 14. So here we get two values of x, one is 13 and another is 14. So now if first number is 13, then other number that is equal to 27 minus 13, that is equal to 14. Okay, so if first number 14, then the other number is equal to 27 minus 14, that is equal to 13. Okay, so therefore the numbers are 13 and 14. Okay, so the numbers are 13 and 14. So here you can verify this. If we take sum, then we will get this is actually 13 plus 14, that is equal to 27. And if we product them, that is 13 into 14, that is equal to 182. Okay, so verified our given information. Okay, so here the two numbers are 13 and 14. Now let us move to question number 4. So in question number 4, here we have to find two consecutive positive integers, sum of whose square is 365. Okay, so student, you know about consecutive positive integers. So like 1, 2 and 2, 3, 3, 4, this type of numbers are called consecutive positive integers. Okay, so here we have given this information, sum of whose squares, that means sum of these two consecutive positive integers is 365. Okay, so now if we use this information, then basically it will give us a quadratic equation. Okay, and now if we solve that quadratic equation, then we'll get two consecutive positive integers. Okay, so let us see how to solve it. So here let the consecutive positive integers be x and x plus 1. Okay, so here we let the consecutive positive integers be x and x plus 1. And here given that x square plus x plus 1 square, this is equal to 365, since sum of whose squares is equal to 365. Okay, so here we get this equation, x square plus x plus 1 square, this is equal to 365, and it implies x square plus 1 plus 2x, this is equal to 365. Okay, and if we simplify this equation, then it implies 2x square plus 2x minus 364, this is equal to 0, and it implies x square plus x minus 182, this is equal to 0. Okay, now we have to solve this quadratic equation. So here we have tool, as a tool, the method, factorization method. Okay, so we have factorization method. So in factorization method, basically we split the middle terms into two terms. Okay, so that product of two terms, that is equal to x squared terms into constant term product. Okay, so here we can split the middle term x as 14x minus 13x, so that if we take the product 14x into minus 13x, that will give you minus 182x square. Okay, so it implies x times x plus 14 minus 13 times x plus 14, this is equal to 0, and it implies x plus 14 times x minus 13, this is equal to 0. Okay, so either x plus 14, this is equal to 0, or x minus 13, this is equal to 0. Okay, so either x plus 14, this is equal to 0, or x minus 13, this is equal to 0. That is x minus 13 is equal to 0, then x is equal to 13, and when x plus 13 is equal to 0, then x is equal to minus 14. So either x is equal to minus 14 or x is equal to 13. So here, since the integers are positive, so in our question we have given the integers are positive, so x cannot be taken negative numbers. Okay, so we here neglect the value of x is equal to minus 40. Okay, so we can take only the value of x equal to 13. So now if we take the value of x equal to 13, then another positive integers will be 13 plus 1, that is equal to 14. Okay, so therefore two consecutive positive integers will be 13 and 14. So the two consecutive positive integers will be 13 and 14. Okay, so now let us move to question number 5. So in question number 5, it said the altitude of a right triangle is 7 cm less than its base, and if the hypotenuse is 13 cm, then we have to find the other two sides. Okay, so basically here in this question we have given a right angle. Okay, and we have given the altitude of that right angle, that is 7 cm, and 7 cm less than its base. Okay, and hypotenuse is given by 13 cm, and here basically you have to find the other two sides. Okay, so here basically here you can use Pythagoras theorem. Okay, so here basically we first let the base of the right angle triangle be x centimeter. So if we have, suppose you have this right angle triangle, so this is your right angle triangle. Okay, so here the base is x centimeter, we let, and its altitude is x minus 7. So this is x minus 7, and we have given the hypotenuse is 13 centimeter. Okay, so here we let the base of the right triangle be x centimeter, then its altitude is x minus 7 centimeter, since the altitude of the given triangle, right angle triangle, is 7 less than its base. Okay, so its altitude is x minus 7 centimeter. So now from Pythagoras theorem we know base square plus altitude square, this is equal to hypotenuse square. Okay, so here base is x, altitude is x minus 7, and the hypotenuse is given by 13 centimeter. Okay, so if we now use Pythagoras theorem, then we get this equation: x square plus x minus 7 whole square, this is equal to 13 square. And if we simplify this equation, then it implies x square plus 49 minus 14x, this is equal to 169. And if we further simplify, then it implies 2x square minus 14x minus 120, this is equal to 0. Okay, so it implies x square minus 7x minus 60 is equal to 0, and it implies x square minus 12x plus 5x minus 60 is equal to 0. Okay, so basically here we use the method splitting the middle terms. So here the middle term is minus 7x, and we split it, the middle term minus 7x, as minus 12x plus 5x, so that minus 12x times 5x, this is equal to minus 60x square. Okay, so now we can now common out from these two terms x, then we get x times x minus 12, and from these two terms we can common out plus 5, then we get plus 5 times x minus 12. Okay, so it implies x times x minus 12, this is plus 5 times x minus 12, this is equal to 0, and it implies x minus 12 times x plus 5 is equal to 0. Okay, so either x minus 12 is equal to 0 or x plus 5 is equal to 0. That is, x is equal to 12 or x is equal to minus 5. So since sides are positive, you know, for a triangle, sides is always positive. The sides are always positive. Since sides are positive, so we neglect here the negative value of x, that is x equal to minus 5. Okay, so here we can only take the value of x equal to 12, so x can only be 12. So therefore the base of the given triangle is 12 centimeter, and the altitude of the triangle will be 12 minus 7, that is 5 centimeter. Okay, so the base of the given triangle is 12 centimeter, and the altitude of this triangle will be 12 minus 7 centimeter, that is equal to 5 centimeter. Okay, so now let us move to question number 6. So in this question it said a cottage industry produces a certain number of pottery articles in a day. It was observed on a particular day that the cost of the production of each article in rupees was 3 more than twice the number of articles produced on that day. If the total cost of the production on that day was 90 rupees, then we have to find the number of articles produced and the cost of each article. Okay, so basically you have given a cottage industry and which produces a certain number of pottery articles in a day, and it was observed on a particular day that the cost of each article in rupees was 3 more than twice the number of articles produced on that day. And if the total cost of the production on that day was rupees 90, then find the number of articles produced and the cost of each article. Okay, so here we can solve by this approach. So here we let the number of articles produced be x. So therefore cost of production of each article is 2x plus 3, since the cost of production of each article is basically 3 more than twice of the number of articles produced by that day. Okay, so this is equal to rupees 2x plus 3, and it is given that the total production is rupees 90. So here the total productions, when the number of articles produced be x, and the cost of productions of each article is 2x plus 3 rupees, so then the total production is equal to x into 2x plus 3, and we have given on a particular day the total production is rupees 90. Okay, so therefore x times 2x plus 3, this is equal to 90, and it implies 2x square plus 3x minus 90, this is equal to 0. Okay, and it implies 2x square plus 15x minus 12x minus 90 is equal to 0. So here we splitted the middle term 3x as 15x minus 12x. Okay, and you can verify that the product of 15x and minus 12x, that is equal to basically minus 180x square. And now if we take out from first two terms x, then we get x times 2x plus 15, and from third and fourth term, if we take out minus 6, then we'll get minus 6 times 2x plus 15. This is equal to 0, and it implies 2x plus 15 times x minus 6. This is equal to 0. Okay, so either 2x plus 15 this is equal to 0, or x minus 6 this is equal to 0. That is x is equal to minus 15 by 2, or x is equal to 6. Okay, so we get two values of x. So here, as the number of articles produced can only be a positive integer. Okay, since the number of the articles produced cannot be a negative integer. Okay, so here, as the number of articles produced can only be a positive integer, so therefore the negative value of x will be negligible. Okay, and therefore x can only be 6. So hence the number of article produced, this is equal to 6, and cost of each article, this is equal to 2 times 6 plus 3, that is equal to rupees 15. Okay, so number of articles produced, that is equal to 6, and cost of each article, this is equal to 2 times 6 plus 3, this is equal to rupees 15. Now let us move next concept, nature of roots. Okay, so the equation ax square plus bx plus c is equal to 0 are given by x is equal to minus b plus minus root over b square minus 4ac divided by 2. Okay, so how this expression, how this formula came, first we derive that. Okay, then we'll discuss nature of roots of the quadratic equations. Okay, so here we have given this quadratic equation ax square plus bx plus c, this is equal to 0. Okay, and now here a does not equal to 0, then we can divide whole equation by a. Okay, and it implies x square plus b upon a times x plus c upon a, this is equal to 0. Okay, and now we have to squaring. Okay, so it implies x square plus 2 times b upon 2a times x plus, here we we'll add b square by 4a square and subtract b square minus 4a square plus c upon a, this is equal to 0. Okay, and here you can see the pattern, x square plus 2ab plus b square, that is basically equal to x plus b whole square. Okay, is x square plus 2xy plus y square, so you can get this is actually x plus y whole square. Okay, so here x square plus 2 into b by 2a into x plus b by 2 whole square. Okay, so this whole thing will be x plus b upon 2a whole square, and the remaining term will be, this is equal to b square by 4a square minus c upon a. Okay, and it implies x plus b upon 2a whole square, this is equal to b square minus 4ac divided by 4a square. Okay, and it implies x plus b upon 2a, this is equal to plus minus square root of b square minus 4ac divided by 2 times a, and it implies x is equal to minus b upon 2a plus minus root over b square minus 4ac divided by 2a, and this is equal to minus b plus minus root over b square minus 4ac divided by 2a. Okay, so therefore x is equal to minus b plus minus root over b square minus 4ac divided by 2a. So this is the SATHEE-ENGG formula, that is known also as quadratic formula. Okay, so by using this formula we'll find the roots of the quadratic equation. Okay, so now we come to this point. If b square minus 4ac, this is greater than 0. So if this expression, which is in the square root, okay, so if this term b square minus 4ac, this is greater than 0, then we get two distinct real roots. Okay, and the roots are minus b upon 2a plus root over b square minus 4ac divided by 2a, and minus b upon 2a minus square root of b square minus 4ac divided by 2a. Okay, and if b square minus 4ac, this is equal to 0, then x is equal to minus b upon 2a plus minus 0. That is, x is equal to minus b upon 2a, and where x is equal to minus b upon 2a. Okay, so when b square minus 4ac this is equal to 0, then the quadratic equation will have equal roots. Okay, now so the roots of the given equation are both minus b by 2. Therefore we say that the quadratic equation ax square plus bx plus c is equal to 0 has two equal roots in this case. Okay, and if b square minus 4ac this is less than 0, then there is no real number whose square is b square minus 4ac. So therefore there are no real roots for the given quadratic equation in this case. Okay, so in this case there are no real roots for the given quadratic equation. So since b square minus 4ac determines whether the quadratic equation ax square plus bx plus c is equal to 0 has real roots or not. Okay, so b square minus 4ac, this is called the discriminant of this quadratic equation. Why this is called discriminant of this quadratic equation? Since b square minus 4ac, this term determines whether the quadratic equation has real roots or not. Okay, so a quadratic equation ax square plus bx plus c is equal to 0 has two distinct real roots if b square minus 4ac this is greater than 0. Okay, and two equal roots if b square minus 4ac this is equal to 0, and no real roots if b square minus 4ac this is less than 0. Okay, so now let us consider some examples. Okay, so now we'll explore some examples on this topic. Okay, so here in first example, here we have to find the discriminant of the quadratic equation 2x square minus 4x plus 3 this is equal to 0, and hence find the nature of its roots. Okay, so here we have given this quadratic equation, and now you can compare this quadratic equation with the general form, the standard form of the quadratic equation ax square plus bx plus c is equal to 0, and you will get the values of a, b and c. Okay, so the given equation is of the form ax square plus bx plus c is equal to 0, where a is equal to 2, b is equal to minus 4, and c is equal to 3. And therefore the discriminant b square minus 4ac this is equal to minus 4 whole square minus 4 times 2 times 3, and this is equal to 16 minus 24, and this is equal to minus 8, and this is less than 0. So the given equation has no real roots since the discriminant is less than 0. Okay, so now let us solve next example. So in next example we have a pole has to be erected at a point on the boundary of a circular park of diameter 13 meters in such a way that the differences of its distances from two diametrically opposite fixed gates A and B when the boundary is 7 meters. So now it asks to us, is it possible to do so? If yes, at what distances from the two gates should the pole be erected? Okay, so basically in this question, we have a pole that has to be erected at the point on the boundary of a circular park of diameter 13 meters in such a way that the difference of its distances from two diametrically opposite fixed gates A and B on the boundary is 7 meters. And we have asked, is it possible to do so? And if yes, your answer is yes, then at what distances from the two gates should the pole be erected? Okay, so let us solve. So here let us first draw the diagram. So this is the diagram. So this is the circular park, and this is the here we have one gate and here we have one gate, and this is the pole. Okay, and here we have given the diameter of this circular park is 13 meter. Okay, so here let P be the required location of the pole, and here let the distance of the pole from the B point be x meter, and here the distance BP is basically x meter. Okay, so this distance is basically x meter. Now the difference of the distances of the pole from the two gates, that is AP minus BP or BP minus AP, that is equal to 7 meter. Okay, so therefore AP, this is equal to x plus 7 meter. Okay, so AP is equal to x plus 7 meter. Now now AB is equal to 13 meter, that is given, and since AB is a diameter, and here you can verify angle APB. This is basically equal to 90 degree. Okay, so therefore by Pythagoras theorem, AP square plus PB square, this is equal to AB square. Okay, so AP is here, AP is here, AP is here base, BP is here altitude, and AB is here hypotenuse. Okay, so AP square plus BP square, this is equal to AB square. Okay, so we basically thanks to Pythagoras, okay, for giving this important and very helpful formula. Okay, for about a very important theorem. Okay, so that is x plus 7 whole square plus x square, this is equal to 13 square. Okay, and now if we simplify this equation, then we'll get x square plus 40x plus 49 plus x square, this is equal to 169. Okay, and if we further simplify this equation, then we'll get this equation 2x square plus 14x minus 120 is equal to 0. And so the distance x of the pole from B satisfy this equation. So now it would be possible to place pole of this equation has real roots. Since to see if this is so or not, let us consider its discriminant. So the discriminant is basically b square minus 4ac. Okay, and if we compare this equation x square plus 7x minus 60 is equal to 0 with the standard form of a quadratic equation ax square plus bx plus c is equal to 0, then we will get the value of a is 1 and the value of b is equal to 7 and the value of c is equal to minus 60. Okay, so here the discriminant b square minus 4ac, this is equal to 7 square minus 4 times 1 times minus 40. This is equal to basically 289 degree. So 289. Okay, so this is greater than 0. Okay, so this is greater than 0. So here discriminant b square minus 4ac, this is greater than 0. So this situation possible. Okay, so it would be possible to place the pole if this equation has real roots. So here for this equation has real roots, so it would be possible to place the pole. Okay, now so the given quadratic equation has two real roots and it is possible to erect the pole on the boundary of the circular park. And now we have to solving this quadratic equation x square plus 7x minus 60 is equal to 0 by the quadratic formula. Okay, so we know the quadratic formula. X is equal to minus b plus minus square root of b square minus 4ac divided by 2a. Okay, so here if we put all the values of a, b and c, then we will get the value of x is basically equal to minus 7 plus minus square root of 289 divided by 2, and this is equal to minus 7 plus minus 17 divided by 2, and if we calculate it, then we will get the value of x is 5 or x is minus 5. Okay, so therefore x is equal to 5 or x equal to minus 5, and since x is the distance between the pole and the gate B, and you know well distance cannot be negative. Okay, so here we neglect the value of x equal to minus 5. So here we will ignore the value of x equal to minus 5. So x can be only only 5. Okay, so thus the pole has to be erected on the boundary of the park at a distance 5 meters from the gate B. Okay, from the gate B, and 12 meters from the gate A. In the next example, here we have to find the discriminant of the equation 3x square minus 2x plus 1 by 3 is equal to 0, and hence find the nature of its roots and find them if they are equal, they are real. So if they are real. Okay, so here A is 3, B is minus 2, and C is 1 by 3. Okay, so therefore the discriminant is b square minus 4c, that is equal to minus 2 square minus 4 times 3 times 1 by 3, that is equal to 4 minus 4, and this is equal to 0. Hence the given quadratic equation has two real roots. Okay, and the roots are minus b upon 2a and minus b upon 2a, and here the value of b is equal to minus 2 and the value of a is 3. So here we'll get the value, the roots are 2 by 6 comma 2 by 6, that is 1 by 3 and 1 by 3. Okay, so I stop here this lecture. Thank you very much to all of you.